Hey guys, today we're going to figure out how to derive the quadratic formula and how to use it with some examples. So first let's start with a linear equation. So linear equations in one variable. So we're all talking about one variable. Let's take this variable as x. So a linear equation would be an equation where the power of x is only 1. So we can have x plus 7 is equal to 12. And here we can see that the power of x is 1, and here we can further simplify it by saying that x will be 5, right? And now you can see that there's only one solution to this equation. There's only one solution, that is x is equal to 5. So only when x is equal to 5 will this equation be valid. That's what a linear equation is. Now for a quadratic equation, the highest power of the variable is 2. Now notice that I say the highest power and it's not the only power. So we can have, suppose, a quadratic equation x squared is equal to 16, or x squared minus 5 is equal to 20, or x squared plus 5x plus 6 is equal to 0. Now these are three types of quadratic equations. Let's see the first one. Here there's only the x square value and it is equal to a constant. Now we can say that x is equal to the root of 16 by taking square root on both sides. But now when you take a square root on 16, you can notice that we have to put a plus and minus sign. Now that is because when you say that x squared is equal to 16, we can say that x is either equal to plus 4 or minus 4. And this is because plus 4 into plus 4, that is 4 square, is equal to 16. But also minus 4 into minus 4 is equal to 16. They're both equal to plus 16. So this can be written as plus 4 the whole square is equal to 16, or minus 4 the whole square is equal to 16. And therefore the square root of 16 will be a plus or minus 4. So x is equal to plus or minus 4. That's the first example. Now the second example over here, x squared minus 5 is equal to 20. Again, we can see that there's only the x square variable. So let's shift the 5 to the other side. So we can get x squared is equal to 25. And when we further simplify it, we can get x is equal to plus or minus 5. Now let's take the last type of quadratic equations, which has both the x square and x. So here we have x squared plus 5x plus 6 is equal to 0. Now in this scenario, what we usually do is split this term as a sum or a difference of the product of this constant term and the coefficient of x squared. So what I mean is, first you have to find out the product of the coefficient of x and the constant without a variable. So that's 6 into 1, that's 6. And now we have to find the factors of 6. Factors of 6 which will add up or subtract. When you subtract them, you can get the value as 5. Now the first thing that should come to your mind is 3 into 2, because 3 into 2 is equal to 6 and 3 plus 2 is equal to 5, and that's what we want. So we can split this term as x squared plus 3x plus 2x plus 6 is equal to 0. And then we can rearrange and take x over here as common and 2 over here as common. So you can get x into x plus 3 plus 2 into x plus 3 is equal to 0. And now taking x plus 3 common, we have x plus 3 into x plus 2 is equal to 0. Now these values are the factors of x squared plus 5x plus 6 is equal to 0. They're the factors of this expression. Now when you say the root or the solution of x, we mean that for what value of x. So roots or solutions of x is basically for what value of x is the equation equal to 0. So over here in this example, these two are the factors, and we can further say that x plus 3 can be equal to 0 or x plus 2 can be equal to 0. Either one of them have to be equal to 0. So we can then say that x is equal to minus 3 or x is equal to minus 2. So the roots of x squared plus 5x plus 6 are minus 3 and minus 2. Now you can plug in these values in this expression and clarify whether it works or not, and it will end up to be equal to 0. Now let's get to the main topic, that is the quadratic formula. Now suppose we have an expression that says x squared plus 4x plus 1 is equal to 0. Now you can notice that there's no way that we can split this middle term as, okay, let's take the non-variable constant and the coefficient of x squared. You'll have 1 into 1 is equal to 1. Now two factors of 1 which add or subtract to plus 4, that's not possible because the only factors of 1 are 1 and 1. So you can have a maximum of 2. But then here the middle term is 4x, and therefore we need another way to find out the roots for this expression. And that is why we have the quadratic formula. Now let's put this in its standard form, and that would be ax squared plus bx plus c is equal to 0. And over here a is equal to 1, b is equal to 4, and c is equal to 1. Now the quadratic formula says that the values of x, the roots of x, can be written as minus b plus or minus the whole root of b square minus 4ac, the whole thing divided by 2a. And this is the quadratic formula. Now let's get to the derivation part of the quadratic formula. So the derivation. Now we have ax plus bx plus c is equal to 0. Now the main thing that we're going to do is try to get this whole equation in a square root form. So that means we're going to want to have x squared on the left hand side so that we can get two solutions for x on the right hand side. So the first step we're going to do is divide the equation by a. Divide the whole equation by a to get rid of this x squared coefficient. So then you're going to get x squared plus b by ax plus c by a is equal to 0. Let's shift the c by a to the other side. So we get x squared plus bx by a is equal to minus c by a. Now on the left hand side over here, on the left hand side we're going to want to have another constant which will satisfy the x plus y the whole square formula. So over here x will be equal to x, that's what we want, and y is what we have to find. So over here y can be written as b square by 4a square, and that is because when you take this as the constant on the left hand side, you're going to get x square plus bx by a plus b square by 4a square, and on the left hand side too you have to add b square by 4a square because it's the whole equation, and you're going to get this as your next step. So here let me write it down here, adding b square by 4a square, and now you'll notice that the left hand side is actually in the form of x plus y. It's in the form of x plus y the whole square, where x is equal to x and y is equal to b by 2a. So if you take that, if you simplify this, you're going to get x square plus y square plus 2xy. So let's plug in these values. You'll get x square plus b square by 4a square plus 2 into x into b by 2a, and that is x square plus b square by 4a square plus b by a x, and that is what we have over here. So then we can write this as x plus b by 2a the whole square is equal to b square by 4a square minus c by a. Now let's take LCM on this side. You'll get x plus b by 2a the whole square is equal to b square minus 4ac the whole divided by 4a square. Now when you take this square to the other side, so let's say after taking square root, x plus b by 2a will be equal to b square minus 4ac the whole divided by 4a square, and the whole taken as root. And also don't forget to write the plus or minus, because you can have two roots of a squared term, negative and positive. And here we can see that we can simplify this 4a square by taking it under the root. So then we're going to have x plus b by 2a is equal to plus or minus root of b square minus 4ac divided by 2a. Now let's shift this b by 2a to the other side. We're going to have x is equal to minus b plus or minus b square minus 4ac the whole divided by 2a, because this is a common denominator. And there you have it. This is the quadratic formula which we had written down earlier over here. Now let's try it with some examples. So yeah, let's take the first example we took, that was x squared plus 4x plus 1 is equal to 0. Now let's plug in the values. A is equal to 1, b is equal to 4, and c is equal to 1. Let's plug in the values over here. We'll have x is equal to minus 4 plus or minus 16 minus 4 into 1 the whole divided by 2 into 1. So x is equal to minus 4 plus or minus 16 minus 4 divided by 2, and then x is equal to minus 4 plus or minus root 12 divided by 2. Now we can further simplify this by writing root 12 is equal to the root of 2 into 2 into 3, and that can be written as 2 root 3. So here we can write x is equal to minus 4 plus or minus 2 root 3 by 2. Now we can cancel the 2 and we'll have x is equal to minus 2 plus or minus root 3. And this is our solution. We can have x is equal to minus 2 plus root 3 or minus 2 minus root 3. And that is all for this video. Thank you for watching.